So what we're looking at in this question is we're looking at graph transformations. Now the graph transformation here is being applied to a logarithmic graph. However, our different sets of transformations and the different ways that we transform the graph, i.e. in x and y, those fundamentally don't change. The only difference here from the graphs that we've possibly worked with in the past is the shape of it and the shape of the logarithmic graph. Now what we've got to do in order to be able to remember how to do this one is figure out what each of the changes do and then be able to illustrate them. Now a key thing you need to make sure you do is any given points on the original graph, you need to indicate where they have moved to in our new graph. We don't have to worry about measuring points and doing lots of other little bits. The key thing is those points that are indicated. So for this one, this point here and this point here, I need to show where they have gone. That's vital in my final graph. Now if we look at the function here, so y equals f minus 1 of x take away 1. So the f minus 1 of x is obviously the inverse, and then I'm going to take away 1 from that. So the first transformation here is to find the inverse of the function, sketch that, and then take away 1. Now, if we're feeling confident enough, we can look and do both transformations in one go on a single diagram. However, if not, I would suggest taking it one transformation at a time in the order that they happen, and then putting your final graph together in one diagram. So if we look at this, the first transformation is obviously going to be drawing the inverse. Now what you've got to remember is the inverse, if we imagine drawing this straight line here, which is going to represent the y equals x line, the inverse of the function is just reflecting it across the y equals x. Another easy way to remember it, particularly for this function, is the inverse of a log is an exponential. Remember, an exponential goes up that direction there. Now if we look at the two key points that we're after, this point here at 1, 0, an easy way to remember it is switch the x and the y parts round if we make the function an inverse. So it's at 1, 0 here, so this point here now moves to 0, 1. This other point here at 3, 1, again flip the two of them around. For my inverse, that'll move to 1, 3. So the rough shape of the curve will then flip to that if it's just the inverse. What I've then done is I've got my second part of my transformation given by this, the minus 1. What that does to the entire curve is it moves it in the y direction down by 1. So every coordinate will move down a full jump in the y direction. So for example, my point that is at the y-axis cutting at 1, that will move down to 0. My point at 1, 3 will move down to 1, 2. It's important to note there's no change in the x direction for it. It's just affecting the y direction. And another thing we've got to remember is that the exponential curve has a limit as it goes off to infinity of y equal to 0. Never cuts the x-axis, never goes below the value of y equal to 0. So we have to illustrate that. Now if I've moved everything down by 1, that means that this value will also move down by 1. So I have to illustrate that this limit, i.e. the line it never crosses, is now down at -1. So if I were to take my set of axes and I were to draw it, and I were to then sketch the curve and how it would look now, what I'd do is I'd keep the same shape I got there when I inverted it, doing it in a different colour just to help with the illustration. I know that it would go through the origin here at 0. I know that my point 1, 3 now occurs at 1, 2, and I know that my limit, which was at 0, now comes to this line here, which is at -1. Now I've shown where those points have moved and where that key information from the original curve now is. I don't have to worry about doing any other points besides that. What it also is useful to do is useful to label our graph and name each of the parts. So name the y-axis and the x-axis. Those will tend to be given in the diagrams you're drawing on in the exam paper. And then name the function so we know what we've drawn. So y is equal to the inverse of the function x minus 1. So there you go, that's what it is. Broken it down into 2 steps. Again, if you feel confident enough and you think you can do it in one go, do it in one jump. Yeah, have a bit of confidence. Jump in with both feet. Otherwise, take it step by step. Just remember the order that the transformations have to happen in, and remember how you do it and how you approach each of them. So this type of question here will typically be worth 3 marks. So your first mark will be for the shape of the curve. So the fact that it changes from a logarithmic shape to an exponential shape and concaves up the way like that, that will typically be your first mark, getting the shape of the curve right. The second mark will be showing where the 2 points have moved to. I said they were vital. Showing where those 2 points have moved to helps to illustrate the transformations and illustrate that you understand what the transformations do and how they can be represented. And the third point will be for showing that limits at y equal to -1. So as we talked about this part here, showing that my limit, which was originally at y equal to 0, has now moved down to y equal to -1 to be reflected in the shape of the curve and what the original one was. So remembering this, remembering how you do each of the transformations, the order that you approach them, the order that you do them in, and what each of them means, if you can do all of that, you'll be able to do it for any curve that appears. Easy peasy, lemon squeezy.